Is it possible to 3D print a ribbon microphone? And if so, what does it sound like? Hey Chogma everybody, it is DShack from Pleasant Noise Productions, and that is exactly what we're doing today. If you've watched any of my other videos, you'll probably realize a lot of times we're taking a step back in time to play with like old analog tape reel-to-reel machines. But today we're going to step a little bit into the future and do something with 3D printing. Now, full transparency before we get into any of this, this is my very first mic I've ever built. This is also my very first time putting a ribbon in anything, and also my very first time with any kind of 3D printing. I designed this from the ground up, from scratch, and I'm really proud that it even works and functions. But beyond that, I'm really excited with how it sounded. My goal was to make a ribbon microphone that I could use here in my own studio to record guitars with, as none of the mics that I have right now am I really that big of a fan of. And I really love Royer ribbons and some of the other ribbon mics I've played with, but they're also pricey. So I set out on this quest to make something that was usable and that I liked here in my own studio. However, I'm going to reserve my thoughts on this microphone till a little bit later in this video, because I want you to hear this microphone in its raw state, unbiased by my opinions, and I would love to hear what you think of it down in the comments below. But before we actually listen to it, I want you to have a little better understanding of what's inside this thing, so you have a better chance to formulate a good opinion. Ribbon microphones are really simple, if not always easy to make, and consist of just a handful of things. You have the body of the microphone, which in this case we 3D printed. You have the ribbon motor, which holds both magnets and the ribbon itself. And you have the transformer, which amplifies the signal, because a ribbon motor's output is really, really small. And even with this transformer, it's still really quiet and requires a lot of gain. For those of you who have used other ribbon mics in the past, you've probably used some kind of mic booster in line even before it hits the preamp with those. And if I had one here, I would use it as well, but unfortunately I don't have one for this test. So the body of the microphone, of course, is 3D printed. That's what this whole thing is about. And the housing for the motor is also 3D printed. All of this, again, I custom designed for this sound and for this microphone. Inside of it are two 1.5 inch long magnets by 3/8 by 1/4 inch, along with a 1/4 inch ribbon that fits in between the two of them, completing the magnetic field. Since this was my first time building a ribbon mic and this is my prototype, I opted to go with a pretty inexpensive transformer to make sure that everything worked. So I chose the Geissnote GN-C36. One major aspect about the ribbon microphone I had to really deeply consider was, since it is 3D printed and there's no metal to help, how can I shield it against electromagnetic interference? A big fancy term to say when you move it close to a power source or something that's drawing a lot of power or a wall outlet, how can I keep it from buzzing and humming from that electricity leaking into the microphone? I had a couple different ideas and thoughts in my mind, but big thanks and shout out to Nicky V, who gave me the idea to use conductive paint and line the inside of this. If you don't know him, he's a great guitar player, session musician, and producer, and has a great YouTube channel, which I'll link down in the description. Since this is a prototype, it's not the prettiest thing in the world. I wasn't concerned with optics, so I didn't paint it except for the conductive paint. I didn't really finish the edges. This was just to test and see if this works. Again, it's my very first prototype. And from this prototype, I can build upon it and make improvements to make this thing sound better. And the last thing to note before we actually start listening to this microphone is that I was using the Audient Evo 16 as my interface and preamp for this. And well, one other last thing, I'm not the one playing on this. I had my friend David Overstreet, who's a great artist and musician, come over, hang out, and be the test dummy for this microphone. You can find his music online and anywhere you stream, David Overstreet, and I'll also link that down below. As always, let me know what you think. I'm really interested in hearing your opinion on this microphone. So, let's get to listening to it.
Now we've never met before, but I know you all too well. And if I saw your face right now, you'd have a good story to tell. I don't know you, but I hate you for the mess you left behind. But I'm not saying that she's off the hook. I still feel beat down and betrayed. But if you thought for 1 minute it was love, then you're just as much to blame. You're so good at playing the victim. Show respect, and maybe you get some in return. Oh, some people never learn. Tried to steal my world from me, but is that honestly what... I just want to know why I am stronger now, I'll be alright.
So what do you think? Do you like it? Do you think it's good? Do you think it's bad? Do you think it's horrible and I should never do this again? Or do you think I should keep going with this? Let me know down in the comments right now. Pause this video if you have to. I want to know your unfiltered thoughts on this and how you think I can improve upon this. But here's my thoughts and observations based off of this very first test. The first thing I'm going to talk about is the noise floor. It's not super noticeable on things like the electric guitar, which has a pretty high output. But for everything else, I had to crank the preamp to the literal maximum. And as such, there's quite a bit of noise. On the low end, around 60 hertz, there is a static hum. Now, I don't actually think that's from this microphone though. Because it's at that 60 cycles per second, I think it's actually probably coming from the preamp and the preamp's inherent noise. Because the preamp is plugged into the wall and drawing source from there, where this microphone is more isolated than that. However, as we go up the audio frequency spectrum and get into those highs, there's a lot of hiss and a lot of kind of garble up there that I do think is probably from this microphone. One thing I intend to do with later designs is upgrade the transformer. Like I mentioned, I went with a fairly inexpensive one, and there's ones that are far better that I've read a number of different people say really improve that signal to noise ratio. And of course, possibly adding an inline mic booster might really help this as well. But while we're also talking about the frequency spectrum, let's talk about a few of the things I heard there. And disregarding that 60 hertz hum that we talked about a moment ago, there is a definite resonance in between 80 and 90 hertz. And that I do believe is from this microphone. Every ribbon, capsule, coil, whatever, has a tuning frequency, and I think that's where this is on this microphone. It was really noticeable in the electric guitars when he would play that low E string. It would kind of pop and buzz and distort there at that 80 to 90 hertz and have this huge hump that tells me there's just some bad resonances there. Moving up a little bit, there's quite a bit of mud in that 250 to 500 hertz range. Now, that is pretty common in a lot of sources. Most things have a fundamental in there or have a lot of information in that range, vocals being one of those things. But this microphone accentuated that in ways that, to me, wasn't all that pleasant. However, when you move up to 2000 hertz to 2K, it sounds really nice. It has a really smooth presence in that range. So I found myself, as I was mixing this, dipping around 300 hertz by 1.5 dB to 2 dB, and boosting 2 kilohertz around the same amount. And that fixed most of the major issues that I was hearing in this. So all things considered, that's a pretty small shift for a first microphone in my opinion. Again, for a first mic, I'm pretty happy with this. Now, as you keep going above 2 kilohertz, you have this natural roll-off. That's to be expected as part of a ribbons design. Although I do wish that this had a little more extension in those highs than it does. All of these things that I just mentioned about the frequency spectrum and response of this, I currently believe is due to the tensioning of my ribbon. If the ribbon's too loose, it's more muddy. If it's too tight, it's too brittle and is really fragile and can get tinny and thin and you have issues. So somewhere in there is this nice balance. And all things considered, I think this ribbon is probably fairly close to where I want it, but I would like it, I think, a little tighter, and I think that'll alleviate a lot of those issues. And from what I've read, I believe it'll drop that resonant frequency a little bit lower beyond that 80 or 90 and maybe get it out of the more usable range. So what do you think? Is this a keeper? Should I build another one? Or should I throw this away and find a new day job? Let me know down in the comments. I want to know your thoughts. I want to know how you think I can improve this microphone. But before we go, I want to show you what this microphone sounds like in context with both a version that has nothing but volume and pan and a version where I've done a little bit of mixing. And you be the judge. Is this a microphone that you would want to use?
You think you're angry? Oh, oops. Here, yeah, just keep it going. I'll start when I'm supposed to start. Not yet. You think that you're angry? Try on my shoes. Think that you're lonely, but see, I'm confused. You deny there's a fire, but you lit the fuse. You think you're angry, try on my shoes. Then you played me at my own game, but you played to lose. You think you're angry, try on my shoes. See, you had a lot of people fool my man, and you almost had me too. Then I burned down the wall that separated the lies from the truth. You think you're cool, you think you're slick, but to be real, you make me sick. You're fat and you're rude, and you smell it too. You tried to steal my world from me. Is that honestly what you thought you could do? See, we've never met before, but I know you all too well. And if I saw your face right now, I'd have a good story to tell. I don't know you, but I hate you for the mess you left behind. Now I'm stronger now than you'll ever be. Don't worry, I'll be fine. Stronger now, be alright. I got regrets, made mistakes, I will pull through, it'll take a little time. I made mistakes, I can't deny. I don't know you, but I hate you. I don't know you, but I hate you. But I'm not saying that she's off the hook, I still feel beat down and betrayed. But if you thought for 1 minute it was love, then just as much to blame. You're so good at playing the victim, show respect, and maybe you get some in return. Oh, some people never learn. Tried to steal my world from me, but is that honestly what you thought you could do? Now we've never met before, but I know you all too well. And if I saw your face right now, you'd have a good story to tell. I don't know you, but I hate you for the mess you left behind. Now I'm stronger now than you'll ever be. Don't worry, I'll be fine. I made mistakes, got regrets, but I will pull through. It'll take a little time. I don't know you, but I hate you. I don't know you, but I hate you. I don't know you, but I hate you.
Yakoke and Chogmashki, thank you for watching. I am really happy about this project. I can't wait to do another one. And let me know what you think I should do next down in the comments. Hit that like and subscribe, and we'll see you next time.